A very good morning to my dear students. Today I would like to explain the mobile internet protocol. So in this mobile internet protocol we have using mobile network layers. In previous lection we can learn the motivation of mobile network layer and what are the terminologies in that and how it will be data will be transferred. And what are the operations of mobile network all are included in this mobile network layer. So those all objectives we can learn in previous session. Let we continue how it will be used. So what is mobile network means? It is a wireless connectivity, and those slides all are we explained in previous section. Okay, in previous section we all learn what are the terminologies mobile IP. So the terminologies are MN means mobile node, and HA means home agent, FA means foreign agent, and COA means care of address, CN means corresponding nodes. So we learn the terminologies of mobile IPs are five types, that is MN, HA, FA, COA and CN. So those are all abbreviation I said in previous session also and this session also. Okay, and next let we use the mobile network layer, how it will be integrated. Okay, see here the network integration will be depend on three factors, that is agent advertisement discovery, registration and routing, encapsulation, tunneling. So these three factors the network integration will be applicable. Okay, firstly we see agent advertisement discovery. Here the agent can do to advertiser how it will be described. Okay, so it will be used the HA and FA periodically send advertisements messages into their physical subnets. So whatever the advertisements he can develop to the agent to discover the network integration, he will be used firstly in home agent and foreign agent. So in between home agent and foreign agent, they can send the information through messages in their physical subnets. Okay, and the mobile node listens to this message and detects if it is the home or a foreign network. It stands for the home network also. And the mobile node reads a care of address from the foreign agent messages. Okay, so the mobile node reads the care of address from the foreign agent advertisement messages. Okay, so here the advertisement will be developed based on the home agent and foreign agent and mobile node. So in between the messages are shared to standard case to a home network also. And the second factor is registration. The registration always limited lifetime. The mobile network signals care of address to it gives the address to home agent via the foreign agent. The advertisement messages will be used. So based on these including of home agent and foreign agent, mobile nodes and care of address, at the same time correspondence nodes, those all are involved to advertise the agent discovery by using of mobile IP terminologies. And registration means the registration always limited lifetime. The mobile node signals of care of address to the home agent via the foreign agent. The home agent acknowledged via foreign agent to mobile node. These actions have to be secured by authentication and routing, encapsulation and tunneling. So here the home agent advertised the IP address of the mobile node as for fixed systems, that is standard routing information, and packets to the mobile node are sent to the home agent independent of changes in care of address and foreign agent. So those all are integrated by using of mobile IP network by using of three factors. Those three factors are agent advertisement discovery, annexed registration, and routing and encapsulation and tunneling. How advertisement agent will be applicable means, here it will be take 32 bits, that is 0 to 31 bits will be taken. Here 32 bits will be taken for advertisement, so 0 to 31. So here the 0 to 31 will be splitted as segmented by using of 0 to 7, 7 to 15, 16 to 23, 24 to 31. So here the 0 to 7 is the type and 8 to 15 is the code and 16 to 24 is 31 is checksum. It will be calculated as checksum value, and this type having the address and code is address size and the lifetime of advertisements. Okay, here they use the router address 1 prefer value, router address 2 preference value 2 level 2. Okay, so based on the router address the preference value will be taken, and again up to so on how router address will be, how many router address will be wanted and how many preference level will be wanted. Based on that will be implemented and so on. Okay, and next here the type and length sequence number will be taken. So the type and length will be registration lifetime and the sequence number is reserved. So based on the sequence number the care of address will be implemented. This is the advertisement of agent. Next, how the registration will be applicable. So the registration will be in based on the terminologies of mobile network, that are MN means mobile node, FA means foreign agent, HA means home agent, MN means mobile node, HA means foreign agent. So this is the form of registration. Here the sequence diagram will be given. The node of mobile is registered request to foreign agent. Okay, then the foreign agent will be request to HA home agent. If the HA is replied to foreign agent, then it will be replied to mobile node. So it will be based on the time. Okay, when the response time and whatever the acknowledgement time will be taken to registration, it will be calculated as the T. And if the mobile network is used for home agent means, then the mobile node is requested to register and the home agent will be given to the reply to the registration acknowledgement. So this is the registration. This is the sequence diagram about the mobile node to foreign agent and the mobile node to home agent. And what is the mobile IP registration request? In this mobile IP registration request, it is, as earlier I said, it will be taken 32 bits, that is 0 to 31 bits, and the IP registration request will be used the type and the sequence time at the same time sequence and the lifetime of registration. Here the home address will be taken and home agent and the care of address will be taken, and what are the identifications are needed, so that extensions will be used. Based on the identification needed information, the extensions are used. Okay, this is the mobile IP registration request. Processing registration message. In this processing registration messages having the scenario by using registration to request message. As earlier we see the sequence diagram how the mobile node depending on the registration on scenario of foreign agent at the same time home agent. So it will be used the link layer address are and the network layer address. So mostly the registration scenario will be used link layer address or network layer address. For a foreign agent may refuse a registration request if a number of reasons the lifetime is too long. For example, if any cases the foreign agent registration request will be refuses, so by the causes are lifetime is very too and authentication is failed and wrong authentication, and next one cannot handle any mobile nodes, some all other reasons if it is refused. And if does not refused, it have the relay of home agent. The relaying of different from the forward as the foreign agent required to the process of packets and create a new header also. Some fields the request message are recorded to use the later on mobile node, link layer address and mobile node IP address also. And the regarding to registration reply message, the FA can refuse it and send to the decline to the mobile node. Okay, and for HA means home agent. So the terminologies abbreviations you must learn, it is very important. HA means home agent. In this home agent, it will be accept to the request if it does not return to the code and reply the message indicated the cause of failed request. If the request is accepted, the reply is sent back by reversing all the IP address and UDP port numbers. And the home agent update the binding table corresponding to mobile node depend upon the nature of the request. And routing and tunneling. In this routing and tunneling, routing a packet to a mobile node involves the following: a router on the home link, possibly the HA advertises reachability to the network prefix of the mobile node's home addresses. All the packets are therefore routed to the mobile node home link, and the home agent the packets for the mobile nodes and turner as copy each care of address also. And the foreign link either the mobile node extracts the packets, and a home agent can use it one or two methods to intercept on mobile node packets. So is based on the home agent is a router and the home agent is not a router. Okay, how does a mobile node router is packets? It's need to find and it can select and it use any router, and it have the DHCP and it uses link layer address to determine for another issues. The encapsulation process is like this. So it will be encapsulated a new IP address to new IP header to outer header. So how it will be encapsulated by the process? Here the original IP header is header, and this is the original data, whatever the data having that IP header is there, and it is new IP header. In this new IP header it will be taken the new data. So this data having the original data In this original data, what is the inner head and what is the outer head. Okay, so the original data having inner header and outer header due to the encapsulation of new IP header based on the original IP header. This is the encapsulation process. The types of encapsulations are, there are three types, that is IP in IP encapsulation means internet protocol to internet protocol. It requires to be supported for fully IP header added to the original IP packet. And minimum encapsulation means it requires less overhead but require the changes to original header. And GRE means generic routing encapsulation. It allows the packets of different protocol suite to be encapsulated by another protocol suite. And the type of tunneling or encapsulation supported is indicated in registration. And the IP in IP, the first type of IP in IP encapsulation is like this. It is the tunneling between home agent and care of address. So in this, the version of IHCL and TOS and length, the identification of flags and fragment offset is there. Here the IP in IP will be encapsulated based on the IP checksum. It is the IP address of HA and care of address. So based on this, the encapsulation of IP to IP is like this. The IP identification of flags, here the IP of CN and the IP of MN is there, and TCP or UDP payload here. So the IP of corresponding node and the IP of mobile node. So all are encapsulated based on the IP in IP encapsulation. It will be reference to RFC 2003 model. And minimum, the second type is minimum encapsulation. In this minimum encapsulation, it avoids repetitions of identical fields. For example, TTL, IHL version and TOS version. Only it is applicable for unfragmented packets, so space left for fragment identification here. So in this, the version of TOS length will be identified of IP identification based on the fragments of offsets, and it will be taken minimum encapsulation the IP address or HA, care of address, layer protocol and reserved IP checksum is there. So in this IP checksum, the IP address of mobile node, the original sender of IP address is, if S equal to 1, then TCP and UDP payload will be implemented. Okay, here the TCP and UDP payload will be implemented by using of original sender of IP address. The IP address is, if S equal to 1, the minimum encapsulation work is done to the repetition of identical fields. And the third one is generic rotating encapsulation. In this generic routing encapsulation, it will be used the original header or original data to GRE header. In this GRE header, it having the new data and new header, and GRE of header is in outer header. Okay, the generic routing encapsulation is used to based on the sequence number, and it is the optional, and it have the key and routing option also here. So here the IP address of HA head home agent and the care of address of COA all are implemented based on the IP checksum. So this IP checksum will be generic router and encapsulation in IP address and of corresponding node and IP address of mobile node. And the routing techniques are two types, that is triangle routing and routing optimization. The triangle routing means it telling in the simplest form as all packets go to home network, that is home agent, and it's sent to mobile node via terminal. Okay, and this involves two IP routers that need to set up, one original and the second one is terminal router, and it caused unnecessary network overhead and add the latency. And routing optimization, the techniques are triangle routing and routing optimization. In this routing optimization, the current location of mobile node and turning its own packets directly problem arise with, and it have the mobility and authentication. If it have the mobility, the corresponding node has to update or maintain its caches, and authentication means the home agent has to communicate with the corresponding node to the authentication, that is security association is with home agent and with mobile node. The change of the foreign agent, if we needed to change the foreign agent, we can follow the sequence diagram how it will be changed and how it will be changes the location in mobile node. Okay, see here, this is the CM means corresponding node and HA means home agent, FA means foreign agent. In this foreign agent old version and this foreign agent new version. Okay, this is the mobile node, how it will be communicate to one another. So here the corresponding node will send the request to home agent and it will be update for acknowledgement from getting the corresponding node. If it getting the corresponding node to home agent, then the data will be moved to mobile agent through foreign agent of old version and new version. Okay, and the MN changes the location. See here, so how it will be changes, the registration will be given to the mobile node is registered give to the foreign agent of new. This foreign agent of new will send the home agent. Okay, if there is any updation, the acknowledgement will be sent, and when the corresponding node will be sent to the mobile node. So here, if the updating is there, then the acknowledgement will be here, then it will be given to the warning for a wait purpose. Okay, if the update will be moved, then the acknowledgement will be taken from the home agent, then the location of data will be sent to corresponding node to mobile node by using of changing a foreign agent of location. Okay, by using of mobile node to changes the location. So here the time will be needed to calculate. And the problems for triangle router is it has some problem. So the problems is firewalls of foreign network may not be allowed, and multitasking is not be allowed, and TTL it may have two mobile node to sustain for communication when it is the home mobile, then it may not be sufficient when moving the round, and longer routes possibilities is there. So for this problem, the triangle router, the mostly solution is reverse tunneling. See here, the reverse tunneling of RF2344 is, see this example here, the mobile node sends to the FA, the mobile node sends to FA, and the FA will sends to the packets through home agent by encapsulation. The home agent will forwards the packets to receiver stand case. So here receive the stand case. This is the C and corresponding node. So based on the reverse turning, the mobile node, actually the corresponding node will send the information to mobile node. In previous class session we see that in this reverse tunneling, the mobile node will send to the data through home agent and foreign agent to corresponding node. This is the reverse tunneling. And mobile IP with reverse tunneling. In this mobile IP with reverse tunneling, the router accepts only of a topology correct address firewall, and the packet from the mobile node encapsulated by foreign agent is now topology corrected, and the multicast and TTL problems will be solved. And reverse tunneling does not solve. The next standard is backwards to compatible. The extension was implemented easily. Here the mobile IP and IPv version 6 we will be see how it will be developed. The mobile IP was developed for IPv4 mobile internet protocol was developed in IPv4, but IPv6 simplifies the protocols and its security is integrated and not to add on the authentication registration included. The CU and it will be used. Care of address can be assigned via automatic configuration and no need to separate the foreign agent, and mobile node can signal to sender directly to care of address, and the soft handover. The mobile node sends the new care of address and it is a older router. The old router encapsulated all the incoming packets and forwarded, and authentication is always granted. The problems with mobile IP is security, firewalls, and QoS, quality of service, and etc. Here the security is the authentication with foreign agent problematic, and no protocol for key management and key distribution has been standard in the internet. The patent and export registration, the firewalls are typically mobile IP cannot be used together with firewalls. The special setup are needed, and QoS is many new registration in case of RSVP, and the tunneling makes it hard to give a flow of packets. A special treatment of needed for quality of services is there. And security in mobile IP is it have the requirements of integrity, authentication, confidently, non-reputational, and traffic analysis, replay protection. Okay, so all are the security. Integrity means any changes to data between sender and receivers can be detected by receiver, and authentication will be used. The sender address is really the address of the sender, and all the data received is really data sent to the sender. And confidentially means only sender and receiver can read the data. No reputation means sender cannot deny sending of data. The traffic analysis is the creation of traffic and use profiles should not be possible. Replay protections is used to receive can detect or apply of the message. The IP security of 1/2 is here two or more patterns have to negate security mechanism to set up a security association, and here the two header have been defined security IP packets, authentication header, and the guarantees integrity and authenticity of IP packets is there. The encapsulation securities of payload also here. So the security architectures are used IP address, authentication header, and UDP or TCP data, and the protection confidentially between the communication patterns are IP header, ESP header, encrypted data, So this IP and the ESP header are not encrypted, and this encrypted data is encrypted to the IP security. Okay students, I hope all of you understand. So let me continue the another section. Thank you.